Howdy, my homies. James Finnerty here with Rewind Electric, and today we're going to be not opening the mail right now, but we're actually going to be testing something that came in the mail yesterday that I already did an opening video of, and we're going to be talking about delays. Not the delays that this robot is experiencing trying to walk across my bench here, and not the delays that anyone who's ordered pickups from me is experiencing, because man, business has just been absolutely overwhelmingly insane and difficult for varieties of reasons. But yes, I'm slow. However, we're going to be talking about the guitar effect delay. And since we're going to be starting and covering a lot of stuff from the 1970s, I thought I'd invite this guy along. This was one of my first toys, and I remember my mom buying them from the grocery store too. And this guy was made in, let's see if we can see right here. I think it says on his foot. Does it say there? Well, I can read it not on the camera, and it says 1977, Tomy, Taiwan. And this guy and he's having a little trouble walking. I mean, he's 46 years old, and he and I are having a little contest to see who can be the one to remain walking the longest between us. And honestly, it's up for debate. I think it's anybody's game right now. So I'm going to put him up here, and hopefully he won't dive off the shelf. My wife made me some really, really delicious iced tea, so thank you to Mrs. Rewind. It's like the passion fruit or something. Okay, delays. Let's talk about it real quick. The first delay pedal. No, that's not it. Did you think it was that one? It's not that one. I understand why you might think it was that one, but it's not that one. If we go back a little bit further, then we get into no, it's not actually not that one either. That is indeed the wrong one too. So let's just say, here we go. The first no, that's a good one too, but that's not it. We gotta go back. We gotta go back some more and really talk about, these early pedals. So now we can get to oh wait, nope. I mean, all great stuff here, but what I'm really looking for is this, the Boss delay machine, the DM-1, the original OG granddaddy of the delay pedal game. So I don't know the dates for all those offhand, but the DM-2, this guy, the purple Boss delay pedal that everyone associates with being the first pedal, and maybe it's the first compact pedal because Boss kind of pioneered that game. By compact, it just, tiny. That would be, and this is a first year, this would be introduced in 1983. So, however, this guy goes back to 1977. I don't know the year off this one offhand, and I don't know the history of those, but I think that might be a 70s also. It could be 78 though. But I think this is pretty sure this is the OG here. As far as analog delays go, there were tape machines before that. Roland, same company, Boss, actually made the Space Echo in 1974. I don't know when Mike Battle, was working with the Maestro Echoplex. I'm not sure when that started. And there were a few other delays as well around that time. Univox made one that got really popular a little bit later. But this was really the first one. Roland, the kings of delays, also after that they went on to do the SDE 3000, the delay units made famous by Eddie Van Halen. And I have 4 of them. I didn't pull them out of the rack to do here, so I'll have to roll in a little. Steve, roll in the clip. I've always wanted to say that. There's no one named Steve here. Sorry. This is Steve, roll the clip. Okay. So yes, here we have a beautiful view of the Roland SDE 3000As. These are rack delay units. So you kind of have your evolution there of tape, analog, and then digital. I don't know the delay times on the SDE 3000s. The DM-1 was up to 500 milliseconds of delay time. This guy was only up to 300 milliseconds of delay time. So they took a little step backwards and they shrunk it down. The other delay pedals I just showed you and talked about, other than the SDE 3000, which is digital, those are all bucket brigade devices. I understand this is a CCD rather than a BBD, which is a charge coupled device. So it's not a bucket brigade device type of delay. It's just a different system. I'm not super confident on that, but we'll find out. Maybe, if I can identify the part when we open it up. So let's get cracking. Okay. I'm not certain what to expect entirely when we get in here, although I would wager to bet it's going to be a full-size circuit board, a transformer, probably somewhere around here near those screws. Some monstrous electrolytic capacitor, or perhaps several. Some type of socketed ICs. Let's see, 1977. Yeah, carbon copper resistors, probably. Not necessarily, though. They did have metal films. Yeah, maybe Boss was or carbon films. Maybe Boss had moved on. Boss always had their eye on the future. I should say Roland. Okay. Okay. I need to get a little slack on this. There's an interesting system happening here. There we go. Where the can you see that? Okay, where this AC lead is actually crimped down here for security, which is fine, and it just passes loosely through here. So okay, I mean it's smart. It's different. It's not what was adopted and continued to be used today, but there it goes. I see a Redicon IC. So I'm familiar with Redicon as being bucket brigade. Now, is that a SAD 1024? No, it's not. It's something entirely different. So maybe that is a CCD. Not to be confused with CCR. Okay, there's a Redicon R5101 8509. I'm sorry to say that doesn't mean anything to me as of this video. I will have to look that up. We definitely have a handful of Marcon, interesting capacitors. You see those different pieces of gear. Those are the big electrolytics. A couple little fuses there. This one is a little bit discolored in the center, unless that's just an optical illusion from the tag underneath it. Yeah. Okay. Quite a handful of trim pots here, including a fancy blue one right there. So I'm gonna brush a little bit of dust off this guy. It's definitely dusty. Start over here. I gotta hold this upside down over the trash can to properly dust it. So please bear with me. Okay, before I do that, let me be a good boy. Short the capacitors, just in case. No, this is not the gentlest way to short capacitors, but it is the effective way to short capacitors. This has been obviously unplugged for at least a week. That doesn't mean that they can't hold a charge, and 1,000 microfarads is not insignificant. Same deal right there. I can't get to the bottom of those, but we'll just have to. We're going to work with what we can work with, all right? By the way, in case it's not clear, this channel is not an instructional on how you should do anything. It's just a watching me learn as I go along kind of thing. Sometimes I can teach you stuff, especially about pickups, guitars. I believe I said recently in a video I'm out of compressed air, and that situation has not changed. Okay, put on my glasses and see if I can get a little more info on anything else that's in here that might be interesting to anyone. So we have Toshiba ICs here. These are labeled TC4016BP, and there's a lot of them. They're 16 pin. No, are they? 1, 2, 3, 4, 5, 6, 7. They're 14 pin. Weird. We've covered the Redicon. This Toshiba IC is a slightly different part on it. It's a TC4069 UBP. And then below it, there's a, these look a little smaller, TC4013P. Got some NEC chips up here that are possibly op amps. There's also a lot of transistors here. You know, an op amp is basically a transistor, capacitors, and resistors in a little package, or a few of them. And that's, you know, you see all these transistor, resistor, capacitor networks down here. And those are some sort of amplifying stage. This is power supply stuff here. Filter caps, diodes for rectification. I bet this is the input, because this looks like input section stuff. Yep. So, kind of basically to me looking like audio in, and then it comes down here and does a bunch of delay stuff, and then audio out up here. Power supply over in this quadrant. Yeah, that's, you get a whole lot more info than that looking at a schematic online. But this is just me kind of exploring this as we go through it together, looking at it for the first time. I'm going to, as I like to do, take some physical measurements of these caps so that I can order replacements to have on hand should I need them. And that's, yeah, sorry, I don't think I'm going to leave that part in the video, but it's necessary for my work. So please forgive me. Or, you know, hopefully if I forgot and I left it in the video, you had a nice opportunity to go use the restroom or get yourself a beverage or something. So, you know, I want to fiddle with all these knobs, but I don't have a schematic in front of me, so I'm not going to do it today. We are going to look at these fuses, though, because it looked as if one was discolored slightly, and we want to make sure that the correct fuses are in here. You know, that somebody didn't have trouble blowing fuses and then pop in something that of 3 times the value so as to stop popping fuses, therefore circumventing the protection and not solving a problem. So these fuses are rated 250 MAT. What is the T? Tiny? It does look a bit discolored. Now, I'm going to need my glasses for that. I don't know if the camera can see that. Let's see. It is, I'm trying to have it focused on the camera and in my eyes. That's like impossible. Okay. 250 volt. Aren't they all? T4AL. 4 amps. Can't be right. 250 milliamps versus 4 amps. That's insane. What does this one say? These are on I don't know. I don't know where they are because I can't see the underside of the circuit. So it's entirely possible that since this is made in Japan, this is a 117 volt unit. Normally the Japanese ones are 100 volts. So that 250 MA could be wrong, but it would be wrong in the other direction. So it's a little concerning. Because if you've got a lower voltage, you're going to pull higher current to get the same power. That's understandable. But if you've got a higher voltage, you're going to pull lower current to get the same power. Well, I have lots of fuses. Some of these are cool vintage fuses that I dig. Let's see what I have in that size format. Perhaps a whole lot of nothing. I need to order a bunch of random fuses is what I need to do. Bojack. So, okay. We kind of discussed it a little bit. I'd like to discuss it again with a more knowledgeable standpoint on it, so I apologize for that. But this thing's so cool, it's worth learning. I think I'm going to make it a point to learn more about analog delays this year because I would like to do a better job at being able to service my deluxe memory man and this and the Ross delay. Although I think I did a video of it. I think I did a pretty good job voicing the Ross delay and the DoD 680 delay. That DoD 680 had some mean clock noise, and that Ross was just too tame. And I was able to move both of them into a position where I like them better. But admittedly not in such an educated, methodical way, but in more of a what happens if I twist this kind of, and like a very basic understanding of what the trim pots in an analog delay unit probably do, and the ability to put them back. That's key. Okay. Okay, so we're gonna take this up on the Variac as I promised. Oh, that noise. Did you guys hear that? Because I heard that and it freaked me out for a second. It was this. Robot's getting some energy out of his legs. He's got restless robot leg syndrome. Okay. All right, let's turn on the benchtop power supply. This thing claims it likes to see 117 volts on the back. We're going to take it there, nice and slow. But the power's off intentionally. Because first, if it's pulling current with the power off, I know there's a short in the power supply section somewhere or something like that. So here we go. We're at 33 volts, 40 volts, 62 volts, 69 volts, 73 volts, 78 volts, and it's still drawing nothing. I'm going to go all the way up just to be sure. Okay, we're at 109 volts and it's drawing nothing. Okay, that's expected. Now I expect it's going to draw, I don't know, quarter amp at most. I don't see it pulling more than that. Okay, 6.2 volts, 13.1, still no current, 19.1, 26, 28, 32, 35, 38, 40, 42. Now it started pulling 0.01 amps. Are we getting anything on these LEDs? Yes. I don't know if you can see that, but indeed, those are glowing. I didn't even know they had LEDs back then. Okay, I'm up to 63 volts and we're still at 0.01 amps. You can tell these lights are coming on. They're lighting up. 86 volts, now we're at 0.02 amps. Can you see those? Glowing a little bit there. Okay, 0.03 amps, and now it's at 115.1 volts. So let's just go all the way up, as close as we can get it. Okay, 116.5. That's going to be as close as I can get it accurately. I've got to move my Delaney brand naphtha out of the way here and plug in the Princeton reverb, and we're just going to throw the volts at this guy full throttle. Bam. I don't like doing that to it. It needs to have its own variac on it. If I was a monster, I'd bolt one to the inside, drill a hole through the cab, and just have a big dial on the side of it. But this amp is really clean. Like if I had another one that had already been messed up, then I might do that. I don't even really like that amp on my bench so much. It's like, it sounds good when you crank it, like pretty much. I mean, it sounds great. I just have some other really nice amps, and I'm holding it to a high standard. But it just is so clean. It doesn't overdrive when it's down low. Unless you put a triangle big muff or a rat in front of it, apparently.